All right, the last section we used some properties and other ways of finding limits. Direct substitution was huge. Obviously, we're going to try that first every single time. But sometimes direct substitution and those properties don't work. So what happens when we're trying to evaluate a limit and those things just don't work out? And that will happen fairly often. Then we get to have fun and we get to do some algebra. So hopefully you're ready for some pretty intense algebra during this lesson because we're going to run into it. Here's why we can use algebraic manipulation. We have two functions here. We have an x squared minus x minus 6 over x minus 3, and we have x plus 2. And I've graphed them for us, and we can see that the graphs are identical except for this one spot right here. The graph on the left has a hole at the spot where x is equal to 3. That hole is filled in on the right because we didn't have a rational function. So everything else is the same. But why? Why could we, or what could we do algebraically to figure this out, that they're the same? Well, x squared minus x minus 6 looks very much factorable. So if we factored that, we would have x minus 3 and x plus 2 over x minus 3. And being the super geniuses you are, we can cancel that x minus 3 and we're left with just that x plus 2. Okay, and knowing what you know from pre-calc and algebra 2, if we cancel something, that creates a hole in the graph. So there's our hole in the graph. Everything else looks like x plus 2. So if we have functions that we're taking the limit of, we can factor and cancel things out and kind of fill in the hole just so direct substitution will work for us. That's kind of the idea, but it can work for all kinds of functions, not just rational ones. So here, a theorem from our textbook, functions that agree at all but one point. We just talked about what that means, and as long as we can do that, we can get something to cancel out, or we can kind of eliminate the problem, as I like to say, then we can use direct substitution and life's good. So we want to, whatever's being divided by, we want to eliminate that if it's a problem. So we have all of these strategies here. First, just be able to see what can be evaluated using direct substitution. Okay, we also want to figure out which ones are going to require us to use algebra. So things that that's talking about are things like simplifying fractions or factoring, maybe rationalizing. It's more common in calculus to rationalize the numerator than it is the denominator, so be on the lookout for that. And very last resort down here at number 3, it says use a table. So only worst case scenario, we can't do anything else, then you want to go to a table because they are very tedious. Okay, so keeping in mind that we're going to factor, rationalize, and simplify, those are the things we want to keep in mind as we look through here. So both of these actually look very much factorable. So let's factor top and bottom and see if we can't actually take the limit at some point in time. So factoring difference in sum of cubes is a formula hopefully you have seen before. Maybe you remember it, maybe you don't. So that first thing we're going to factor. We have to write this limit notation every single time. So if you don't, it will be wrong. So difference of cubes factors into x minus 1 and then x squared plus x plus 1 over x minus 1. And then we can see that our x minus 1's will cancel out. So this limit now, we have the limit as x approaches 1 of just that quadratic piece. And quadratics are well-behaved functions that we talked about in 1.5, so this can be evaluated by direct substitution, and we can say that this limit is equal to 1 plus 1 plus 1, so 3, and we have our limit. Okay, if you want to check on a graph or a calculator or a table, you certainly could. The one on the right is basically the same idea, just a bit different factoring because it's bigger numbers. So x approaches 3. If we try direct substitution, we know we're going to create division by 0. So 3 is a problem, so we're going to eliminate that x minus 3. So it's cubed root of x cubed and cubed root of 27. Square the first, subtract the product, add the square of the last over x minus 3. And again, we see that the problem has been eliminated, and now we can just have fun evaluating this. Quadratic, and 3 squared, 9 plus 9 plus 9, so 27. So factoring is really nice. Not often do we actually have to factor difference of cubes. Most of the time it's other things. All right, these are a couple different ones. So the one on the left, really there's not much factoring we can do to get that h to cancel out, but we see down here that h is going to 0 and it's all by itself in the denominator, so that is a problem that we need to eliminate. So there's no factoring we can do, we got to do something else. The only thing I see to do right offhand is maybe we just have to square that 3 plus h that it's asking us about. So limit h approaches 0, got to write that every single time, guys. Squaring those, remember the binomial theorem, so it's 9 plus 6h plus h squared minus 9. So this is like one of those simplify things. We're just simplifying things, finding out what cancels out. We get a 9 and 9 that cancel. And then notice all of our terms left in the numerator have a common h. So we're going to factor out an h from the top. So it looks like h times the quantity 6 plus h over h. Then we simplify again, and now finally we have that problem eliminated. So it's the limit as h approaches 0 of 6 plus h. Now finally direct substitution works. 6 plus 0 is 6, and we have our limit. So that's what that simplifying idea sort of looks like. You just kind of do what needs to be done and hope things cancel out. The one on the right has a radical. Radicals are when you're going to use that rationalizing technique. And notice our radical is in the numerator, so we will rationalize the numerator. So to rationalize numerator, this is what I'm multiplying by. Square root of t squared minus 9 plus 3, multiplying by that conjugate, top and bottom. And the rationalizing gets really messy in the middle, but ends up a lot better in the end. So we have to very carefully FOIL the numerator. So t squared minus 9, t squared minus 9, those radicals cancel out. So that's just t squared minus 9. The inside and the outside in FOILing cancel, and I have a minus 3 and a plus 3, so that is minus 9 over t times t squared, plus 9 plus 3. Sorry, I wrote that wrong. That was supposed to be square root. All right, so we want to get things that are going to cancel out. And I believe I have a typo in the original problem because this was supposed to be t plus 9. So that was my fault on the typo there. Now we see that things are canceling. We can see a positive 9 and a negative 9 cancel out. And what's causing our problem in this one is just that t. And notice I didn't distribute the t through here. That would have made life a lot more difficult because that's what we want to get to eliminate anyway. So don't distribute that, just let it hang out there. And now we can cancel one of the t's from the top and the t on the bottom. So we have the limit as t approaches 0, 1 t left on top, and the denominator is just t squared plus 9 plus 3. Okay, again, that's t squared plus 9 because I made the typo at the beginning. Now, direct substitution, try it out again. We shouldn't get anything crazy in the denominator, like division by 0 or anything. So we're going to have 0 over 6, which is just a limit of 0. Okay, the rationalizing one probably is the most difficult from today's lesson, but it's still kind of fun. I hope you enjoy it. Let's look at these last two and see what we can figure out. The one on the left, how do you think we should tackle that one? Is it a simplify, is it a rationalize, or is it a factor sort of situation? Hopefully you all said rationalize because there are radicals. And we know that x by itself on the bottom is a problem because x is going to 0. So I'm going to multiply by a conjugate, which is x plus 2, or square root x plus 2 plus root 2 over itself. And when we rationalize, we're still here writing limit as x approaches 0. That notation has to be every single line until you do direct substitution. So when we FOIL this, we're going to end up with x plus 2 minus 2. And the denominator, don't distribute in the denominator. You want that to cancel out anyway. Right? So we get our positive 2, negative 2 to cancel out. And then you can see right now that this x on top and that x on the bottom will indeed cancel as well. So we'll have the limit as x approaches 0. Everything canceled in the numerator leaves us with 1, not 0. Square root of x plus 2 plus root 2. Okay, x is going to 0, so now I can try direct substitution again. And it's going to work, so I don't need to write the limit anymore. That goes away. 1 over, that would be the square root of 2 plus the square root of 2. That's 2 square roots of 2. All right? And now that we're in calculus, radicals in the denominator just don't bother us anymore. So we can leave that as 1 divided by 2 over, or 2 root 2, and call it good. No more rationalizing denominators to simplify answers. That is not a thing in calculus that you need to do. So, happy day, right? How about the last example there? Nothing to rationalize because there's no radicals. There's nothing to really simplify. We can't add or subtract or square things or do anything. And we do know for sure that 7 is causing a problem down here, so that x minus 7 needs to go away. So what's left? Everybody's favorite fun, everybody's favorite thing. Factoring, of course. So we're going to factor the limit as x approaches 7. Now, if I were willing to place bets on this, I would need an x minus 7 to cancel with the x minus 7 on the bottom. So that might help us factor if we're having any sorts of trouble with that. But factoring quadratics is something that hopefully you're really good at because it does happen a lot. So to get 2x squared, I need a 2x, I need a 1, and I need that one to be positive. Okay, now my x minus 7's cancel out. I can write my simplified limit as just 2x plus 1, and now direct substitution works. So 2 times 7 plus 1 should be 15. And we have our answer. So, big things today. You get to do quite a bit of algebra, and then your notation, your limit notation has to be written every single time until you actually do the direct substitution. So make sure you are writing that notation all the time. That should be it for today. Good luck on your homework. Let me know if you have questions.